Bismillahirrahmanirrahim. Assalamu alaikum. Today we will discuss the paper 4 and we will solve question number 1, that will be the titration, and we have taken the specimen paper 4 of the year 2023, and this is the question number 2. A student investigates the reaction between sodium carbonate and two different solutions of hydrochloric acid labeled as A and B, and the equation for this reaction is sodium carbonate is reacting with hydrochloric acid. It's metal carbonate and acid reaction, so it will produce salt, water and CO2, right? So the student follows the instructions for 3 experiments. Means in this question we will discuss 3 experiments, right? Experiment number 1 is that in this experiment 1, use a volumetric pipette to add 25 cm cube of aqueous carbonate, sodium carbonate, in a conical flask. So in conical flask, as you know, in titration we use pipette, burette, conical flask, these all apparatus. In conical flask we will take 25 cm cube of the solution that will be of sodium carbonate, right? And then we will fill the burette with solution A, and solution A is hydrochloric acid, right? And then we have to record the initial burette reading, add solution A from the burette until the solution turns colorless, record the final burette readings. This is the complete process of the titration experiment. So now when a student performed the experiment 1, he got these readings. 13.2 was the final reading. Initial reading, as you know, that is 0. So how we will calculate the volume? By subtracting initial reading from the final reading, so that will be 13.2, right? So this is the experiment number 1. Then look at here, experiment number 2. Now we have to perform this experiment by using, there is only change of the indicator, that is methyl orange. In the above experiment, look at here, the indicator is thiophthalate indicator, and in our previous lecture we discussed the colors of these 4 indicators, which are, these are the indicators. Number 1, methyl orange, red in acid, yellow in base. And in this the question, we will discuss the color of methyl orange as well, red or orange to yellow, then phenolphthalein colorless to pink, then thiophthalate colorless to blue, and litmus red to blue. So these are the indicators which are very important for acid base titration. Now in experiment number 2, we are using the indicator methyl orange, and we replace the indicator thiophthalate. So as you know that the color of methyl orange, we have discussed that it will be red in acid or orange, and in base it will be yellow. So these are the readings of the initial titration, initial reading and the final reading. So initial reading is 12.8 and the final reading is 39.2. So we have to write final reading, that is 39.2, and initial reading is 12.8, And how to calculate the volume? By subtracting initial burette reading from the final, so it will be 26.4. Now look at here, the indicator we have used, that is methyl orange, right? In acidic solution it will be red, orange and yellow in alkaline solution. So state the color change. So it, look at here, it will be from yellow to red. Why it will be from yellow to red? Because we have, taken the uh, uh, sodium carbonate solution in conical flask, and then we have added few drops of methyl orange, and then we have titrated it with the acid, that is hydrochloric acid. So it will turn from yellow to red, or orange, yellow to orange. And if we have taken, the acid in conical flask, so then it should be from red to yellow. So now look at here, the question number B is that state one observation other than color change that is made when dilute hydrochloric acid reacts with sodium carbonate. So this is basically acid, reaction of acid with metal carbonate, so it will definitely produces the CO2 gas. So what will be the observation of CO2 gas? Look at here, fizzing or effervescence or bubbles of gas will be given out. So this is very easy question. Now look at here, experiment number 3. What will be the change in experiment number 3? So the change is that we have to use the solution B of acid, and we will replace solution A. We will use the solution B, that is also of hydrochloric acid, but maybe the change in the concentration. Now look at here, the readings which we have obtained here. These are the readings. So initial reading should be, it should be like that. Initial reading should be 9.9, and the final reading should be the 16.5. So when we will subtract it, we will get 6.6. This, the table should be like that, right? So now question number E is that in which experiment you people have used the largest volume of the hydrochloric acid to change the color of the indicator. So now look at here, we have used the volume of the acid we have used, that is, look at here, in experiment number 3, that is 6.6, and in experiment number 2 we have used 26.4, and in experiment number 1, when you go through the it's 13.2. so in experiment number 2 we have used the highest volume of acid. That's why we have written the experiment number 2. Then next question is that state the effect of the on the volume of the solution B used in experiment 3 if the aqueous sodium carbonate is warmed before adding solution B. So this is basically acid base reaction, acid base or acid metal carbonate or acid metal oxide reaction. So in this reaction, when you warm metal carbonate or base, there will be no effect because the concentration. So in experiment number 2 we have used the largest volume of acid, as we have already discussed, and then we were discussing about the effect when we add sodium hydroxide, when we reacted sodium hydroxide and we have just warmed it. So there will be no effect because the concentration is same, we are not changing the concentration. So the answer will be no effect, and then we will write it's because that concentration is not changed, it's same. Then in the part G, question number 1, calculate the simplest whole number ratio of the volume of solution A hydrochloric acid used in experiment number 1 and the volume of uh, the solution B hydrochloric acid used in experiment number 3. So look at here, in experiment number 1 and 2 we have used the volume of solution A, that is 13.2, and then in 2 16.6.6. So when we uh, you know uh, get the ratio of these two volumes, so it should be 2:1. So we have written here 2:1. Then in the part 2, calculate the simplest whole ratio of the concentration of A and B. So look at here, uh, the volume we have used, that is 13.2, and then that's in greater amount. And in the experiment number 2 we have used the volume, that is 6.6, means the concentration should be greater here and the concentration should be less here. So the ratio we will take, that should be 1:2. So we have written here 1:2. Now the last second last question is very easy. The burette is now empty and reused for experiment number 3. So the question is that suggest an additional step after emptying the burette, which would improve the accuracy of the results. So the answer should be, we have to start the reaction, we have to start the experiment, and then we have to fill the burette again with the solution B, and then we will perform the experiment number 2. So I have written here, rinse the burette with solution B. 1 mark you will get when you have written rinse the burette, fill the burette, and then 1 mark you will get uh, by the solution, which solution you will put into the burette, that will be solution B. Now last, titration often give inaccurate results if done only once. So what will be the step to get more accurate readings? Suggest how repeating each experiment several times produce more accurate values. So that's very easy, that when we repeat uh, the readings or the steps, so what will happen, until we get similar results, then we will calculate these, we will note down all these readings and take mean, then we will get the accurate result. So the answer should be repeat until the similar results are obtained, and then you have to calculate the mean of the similar results. So the total marks for this question number 1, titration, are 14 marks. Thank you. Inshallah we will upload, I will upload the questions, other questions related to the ATP paper 4. Allah Hafiz.